but we're going to talk about applications of sets. All right. So really, you're just going to do word problems that Venn diagrams are going to work really well for. So you have a bunch of information that's not displayed too nicely, and then we want to answer some questions with it. So we're told Panera Bread compiled the following information regarding 30 of its employees. The following was determined. So basically, those 30 employees have certain positions. They could do one thing, but not the other. So we have 8 people in total that can cook food. There are 9 people that know how to wash the dishes. There are 18 people that can operate the cash register. And this talks about everyone. So there's definitely overlap. Some people can do multiple jobs. So there are 4 people that can cook and wash dishes. There are 5 people that can wash dishes and operate the register. I'm going to put this on a new line so I can draw my Venn diagram next to it. There are 3 people that can cook and operate the register. And then there's 2 people that can do all 3 jobs. Okay. Number one thing that happens is you literally just put these numbers exactly where they belong. So 2 people go in the middle, 3 people go where they cook and operate the register. That's not true. If you add up all these numbers, it's definitely more than 30 people. So there is overlap. I'm talking about multiple people. The cash register circle should contain 18 people in total. Okay. So when I make my Venn diagram for this, I've got to account for the fact that there is overlap. So I'm going to draw 3 circles again, make them more like oval-like. That'll be circle A, circle B, and then circle C. Good enough. Going to be funky, but that's fine. This way I can fit all of my writing in it. This will be the circle for people that cook food. This will be our circle for people that can wash the dishes. And then the cash register will be this one at the bottom. Okay. So you still always start smack dab in the middle. There are 2 people that can do all 3 jobs. So in this center circle, if my pen doesn't want to keep breaking this up, there are 2 people that can do everything. So 2 people in the middle. Okay. Now I have all of this overlap between these regions. They tell me there's 4 people that can cook and wash dishes. So there should be 4 people in this complete overlap here. But I've already accounted for 2 of them. Let me use a color you can actually see the difference with. So 4 people should be in this region completely. There are 4 that cook and wash dishes. 2 of them are here. That forces 2 to be left in this region. Okay. So in all of these, we need to subtract 2 accounted for in the very middle. Okay. So in this first region, there's 4 people that cook and wash dishes. So from 4, we need to take away 2 in the middle. There are 2 people that solely cook and wash dishes, but not do the register. Okay. Then if we move on to the overlap between dishes and the register, that would be right here. From 5, we've got to take away the 2. There are 3 people that only wash dishes and do the register, but not cook. Okay. Then we move on to this overlap between cooking and the register. Use a different color. Need more colors. Did that color. What else can I do? Did orange. Let's do a dark green. That sounds good. Okay. So from the 3 people in total, we've got to take away 2 in the middle. There's 1 person that cooks and does the register, but does not wash dishes. Okay. Now for each of these larger regions, I have 8 people that cook food. So there should be 8 people in entirety in this circle. So when I go for the people that their only job is to cook food, I've got to take away all the ones that I've accounted for in these other circles. So from my 8 people in total, I take away 2, 2, and 1. Because they've already been placed in some location. So there are 3 people that just cook. Likewise, when we go to the people that solely their job is only to wash dishes. I have 9 people in total, but I have 2 accounted for here, 2 here, and 3 here. So from 9, we take away 2, 2, and 3. There are 2 people that only wash dishes. And then finally, for our register, there are 18 people in total, so that's the entire circle. So from 18, we got to take away the 1, 2, and 3 that are already used up. There are 13 people on the register. Okay. But now I still got one more region I haven't used. And that's going to deal with these 30 people in total. So I have 30 employees. Some of them probably don't do any of these jobs, probably the managers. They're not really doing any of this. So I still have to talk about this region outside the 3 circle. See if I can color it in somewhat nicely without taking forever to do so. Wish there was a drag and drop and self-color in, but unfortunately not. So when we want to find the number of people that didn't or that don't cook, wash, or operate the cash register, from these 30 employees, I've got to subtract the numbers we have accounted for. So that's the 3, 2, 2, 1, 2, 3, and 13. So from 30, we're going to subtract all of those quantities. The 3, the 2, the 2, the 1, the 2, the 3, and the 13. And if you do that, there are 4 people we have unaccounted for. So there are 4 people that fall outside of this region. Okay. So this is actually the first part of the problem. Part A is construct a Venn diagram. And now that we have the Venn diagram, we're going to utilize that to answer some questions. So now we want to figure out how many of the employees first only cooked food. Okay. And so I've got that taken care of. People in just the cook circle is 3. Next one, how many of the employees only operate the cash register? And that would be our 13. Now we're going to get into some funner questions. How many of the employees did at least 2 jobs? Okay. And so I'm going to put a little mini Venn diagram here to talk about or figure out what we're talking about. Here's our 3 sets. If they did at least 2 jobs, that would be anything where these circles overlap. So if they did 3 jobs, they definitely did at least 2 of them. Okay. So I want the overlap. So that would be 2, 2, 1, and 3. So we go ahead and add those together. So 2, 1, 2, and 3. There are 8 people that did at least 2 jobs. Okay. And our last question for this one is we want to figure out how many of the employees wash dishes or operate the cash register but don't cook food. And so again, I'm going to turn to my Venn diagram to help us out. If they wash dishes or operate the cash register, they would be in these 2 circles, but we don't want the ones that cook food. So we ignore the stuff in the pink circle. So really, I want how many people lie within these regions. Okay. They don't care about the stuff in the pink. So looking at those, that's 2, 3, and 13. So we just add those together. So there are 18 people that can wash dishes or operate the cash register, but they don't cook food. Okay. So this is pretty much what you're going to do for every single problem. Create that Venn diagram, making sure you subtract constantly. The only thing that you can immediately put down is the thing in the dead center. Then you've accounted for those people, so you've got to subtract quantities constantly. So I'm going to do one more example. Same kind of idea. We'll work with slightly larger numbers this time. But a travel agency surveyed 125 potential customers. And the following info was obtained. So we have people that are willing to go to 3 different places potentially. 68 wanted to travel to Hawaii. 53 would travel to Vegas. 47 would travel to Disney. And now there's people that were willing to do more than one spot. So 34 would travel to Hawaii and Vegas. 26 would travel to Vegas and Disney. 23 would travel to Hawaii and Disney. And then 18 would travel to all 3. Okay. So I again want to construct my Venn diagram, and then I'm going to answer some questions. And I'll try to do all the math inside of the Venn diagram. So I've got 3 circles. I need to have a Hawaii circle. I need to have a Vegas circle. And then I need to have a Disney circle, which I could shrink a little bit. So here will be our Disney, our Vegas, and our Disney. Okay. So always start right in the middle. 18 will do all three. And I'm going to even go ahead and box it so this way you can kind of clearly tell what the number is going to be. And then I'm going to move up the line. If I want Hawaii and Disney, that's going to be this region here that I need to fill in. There are 23 people in total. I've accounted for 18. So there are 5 people that will solely go to Hawaii and Disney. Then I just keep moving down the list. 26 are willing to go to Vegas and Disney. But I've accounted for 18 of them. So there are 8 people that fall into this region. Okay. And then we look at the overlap. 34 will go to Hawaii and Vegas. 18 are already in the middle. So from the 34, we have to get rid of those 18 people. There are 16 that want to just do Hawaii and Vegas. And now I'm left with these last 3, 47 will travel to Disney, but I've accounted for 5, 18, and 8. So from the 47, we get rid of 5, 18, and 8. And if you do that, there are 16 people willing to go to just Disney, but not the other 2. Okay. Now we move on to Vegas. I have 53 people in total, but I've got to get rid of the 16, 18, and 8 already accounted for. So there are 11 people that want to go to Vegas, but not the other 2. And then last but not least, well, not quite last, so we still got the outer area to account for. The last circle is our Hawaii circle. So from the 68 people, we've got to take into account, we put 16, 18, and 5 in places already. So there are 29 people in this region. Okay. And then on the outside, we have 125 potential customers. So I've got to get rid of all of the people we've accounted for. So from 125, we've got to subtract 29, 16, 11, 5, 18, 8, and 16, which leaves us with 22 people that fall on the outside. Okay. And now that our Venn diagram is set up, we can go ahead and answer some questions. So we want to figure out how many people first did not want to travel to any of these destinations. Okay. And that would be our 22 people sitting on the outside. And the second and final question I'm going to ask about this is how many wished to travel to exactly one of these destinations? Okay. And so that's going to be the ones that are unique to each set. So we've got all of our 3 sets. if they wanted to travel to exactly one, that would be this region here. Need to make this tool a little bigger. This region here. And this region here. So that would be 29 people that wanted to go to Hawaii, 11 to Vegas, and 16 to Disney. Adding those together gives us 56 people that wanted to go to exactly one destination. Okay. All right. So I just have one last example, a much shorter one, only 2 Venn diagrams or 2 circles, and that will be it for this section. So we can kind of utilize this to tell if someone we've hired for a survey has done something accurate or if things actually make sense based on what we're told. So to Tullio's restaurant, hired Dennis to determine what kind of appetizers customers like. Okay. He surveyed 100 people and got the following results. Okay. He was told that 78 people, or he told to Tullio's, 78 people liked mozzarella sticks. 56 people liked fried calamari. And there were 35 people that liked both. He also said every person interviewed liked at least one of the appetizers. Does this result seem correct? So we hired this guy to do the survey. We want to make sure it works out correctly. Okay? Don't want to just accept it at face value. Let's do a Venn diagram, because I definitely have some overlap. Got our universal set here. We've got people that like mozzarella sticks. Just put mozz there. And then we've got our fried calamari circle. And based on the information he has given us, we know there are 35 people that like both. So that's what goes right in this middle region here. When we look at just the mozzarella sticks, there are 78 people in the entire circle, and we've accounted for 35 of them. So from 78, we've got to get rid of the 35 accounted for. There are 43 people that like just mozzarella sticks. And then likewise, 56 like fried calamari. So this entire blue circle should contain 56 people, but 35 of them are in the middle. So there are 21 people that like just fried calamari. So he told us that everyone liked at least one of these. So if the results are correct, there should be 0 people on the outside of the circles. since everyone liked at least one appetizer. Okay. So based off that, if we add these together, 43 plus 35 plus 21, that's 99 people. But I surveyed 100 people in total. So if I do 100 minus 43 minus 35 minus 21, I get one individual out here. Okay. So one person belongs on the outside. And doesn't like either appetizer. Okay. So his results aren't accurate. He said every person liked at least one of the appetizers. So these results don't make sense. So we paid this guy to do his job, but he didn't do it correctly, which is a huge problem. So something went wrong. Either he miswrote the evaluations. We don't know, but we definitely shouldn't be paying this guy until he fixed the problem and redoes it for us. Okay. So this is what you're going to do every single time for one of these problems. Just remember there's overlap. We always start right in the middle every single time, and then we have to go back and delete the people we've already accounted for. So you don't want overlap. Right? Don't just place those numbers down exactly where it tells you. Really common misconception is you have 5 people that wash and operate the dishwasher, then you're going to put 5 people right here in that region. And that's not going to be true. So just be cautious with these problems. Okay. But that is it for this last section. And that is it for chapter 3 or chapter 2.